This is a tutorial on graphing radical functions, in particular graphing square root functions in the form of y is equal to a times the square root of bx minus h plus k. I have an algorithm that I kind of think through as I graph each of these functions, but I think I'm going to just show you this by graphing a few examples and letting you know what's going on as we go through them. However, I do want you to see this is the parent function, y is equal to the square root of x. It begins at the actual origin and heads off in this direction. Notice the domain of this function is actually 0 to infinity because I can't take the square root of a negative number in the real plane. And even though I'm going to show you how I would graph that in the next slide, if you get an idea of the way this parent function looks, then as we translate them up, down, left, and right, you'll be able to have a better understanding of what your graph should look like. Okay, to begin, I'm going to just graph y is equal to the square root of x. Once again, I look at my domain by setting what's underneath the radical greater than or equal to 0. X is greater than or equal to 0 tells me that my domain, pretend that's a D, my domain goes from 0 to infinity. The origin of this square root graph is going to be 0, 0. Why? Because what's underneath the radical would be 0, and what's outside the radical is also 0. I begin at 0, 0. That kind of tells me already my y-intercept is 0, 0, and I have a 0 at 0. I don't have a whole lot of other points to work with here, so what I think I'm going to do is just pick a few points that might help my graph a little more. Well, I know the square root of 4 is 2. For that matter, I know the square root of 1 is 1, and that should be enough points to get me a pretty good idea of the direction of this graph. It may look like this graph could have a horizontal asymptote somewhere. Actually, it doesn't. The range of this graph is 0 to infinity. One of the ways that you could probably tell yourself that is let's pick any y value that you want, maybe 1,000,000. Could I possibly get up to 1,000,000? Well, if my x value is 1,000,000 squared, when I take the square root of 1,000,000 squared, I get a y value of 1,000,000. And you can do this for any positive y value whatsoever. Just square the number. That would be an x value that would give you your y value. So you know your y value isn't going to stop at any real number. It's going to actually the range is going to head up to infinity. All right, a little tougher here. Now let's graph y is equal to the square root of x plus 4 minus 2. First thing I want to remind myself, the domain is going to take whatever is underneath the radical, set it greater than or equal to 0. X plus 4 is greater than or equal to 0, tells me x is greater than or equal to negative 4. And this time my domain is going to go from negative 4 to infinity. The origin of my graph, in this particular case, I'm going to find by the x value of the origin by setting x plus 4 equal to 0. My x value of the origin of my graph is negative 4. The y value is the part that is outside the radical. It's negative 2. This graph begins at negative 4, negative 2. Once again, this graph isn't reflected anywhere, so I know the basic shape of the graph is going to be something like this. However, let's see if we can make it a little bit further along. Does this graph have a y-intercept? Well, I find the y-intercept by setting x equal to 0, and if I set x equal to 0, 0 plus 4 is 4, square root of 4 is 2, and I get, well, let me work this out for you real quick. I'm going to put y is equal to the square root of 0 plus 4 minus 2. Square root of 4 is 2. 2 minus 2 is 0. So when x is 0, y is 0. My origin of my graph is negative 4, negative 2, but it actually passes through the origin of this Cartesian graph. And so I've got 2 points. We'll get basically the shape of my graph. If you needed another point, you would be welcome to do so. Pretend I actually went through the origin of the graph there. See if I can slide this thing back a little bit. And there's the shape of my graph. The range of this graph is negative 2 to infinity. It was 0 to infinity, but I moved the graph down 2. That's going to change the graph's range to negative 2 to infinity. How about the graph of the square root of 5 minus x plus 1? This isn't really in the standard form I was given to you earlier. The standard form would look something like y is equal to the square root of negative x minus 5 plus 1. Though I don't even think I need it. I think the algorithm that I give you should be fine without even trying to put this thing in standard form. First of all, I want to figure out what's the domain of this graph by setting what's underneath the radical greater than or equal to 0. So I'm going to say 5 minus x is greater than or equal to 0. 5 is greater than or equal to x, so x is less than or equal to 5. The domain of this graph actually goes from negative infinity to 5. Why? Because this negative in front of the x here means the graph is going to flip horizontally. So in this particular case, my graph, instead of heading off to the right, is going to head off to the left. Well, 5 minus x equals 0 tells me the x value of the origin of my graph is at 5. I find the y value of the origin of my graph out here. This graph is going to actually start at the point 5, 1. Heading off to the left, or towards negative infinity. I want to figure out what is my y-intercept by setting x equal to 0, and I will get y is equal to the square root of 5 minus 0 plus 1, which is the square root of 5 plus 1. Well, the square root of 5 is approximately 2.236. If I add 1 to that, I would get 3.236. I don't think I can graph that exactly, but it's really close to 3 1/4. So I'm going to put my y-intercept here at right about 3 1/4. And how am I going to write it? Well, I'll just write, I know my x value is 0. My y value is the square root of 5 plus 1. How about an x-intercept? Well, if you notice that the shape of this graph is heading up here, or the direction of the graph is heading up, you'll realize that I will never cross the x-axis. You could try to set that equal. Well, let's do it real quick. Let's say I didn't realize that, and so I'm going to try to set my graph equal to 0. 0 is equal to the square root of 5 minus x plus 1. That tells me that the square root of 5 minus x is equal to negative 1. Well, this is the principal square root. It's going to be a positive number. Can't be a negative number. I won't get an x-intercept. I won't get a 0. So I can just draw my graph from here. What's the range? In this particular case, my range is actually going to go from 1 to infinity. All right, last graph before you try some on your own. I put a lot of stuff in this. Y is equal to negative 1/2 times the square root of 4 minus 4x plus 3. As before, I want to know what's the domain of my graph. I'm going to do that by setting what's underneath the radical, 4 minus 4x greater than or equal to 0. So 4 is greater than or equal to 4x. So 1 is greater than or equal to x. X is less than or equal to 1. The negative in front of that 4x meant the graph is going to actually be flipped this way. Now I know it's got to go upside down, but I haven't done the work to make this thing go upside down yet. Why do I know it's going to be upside down? Because I've got a negative out front. That's actually going to make the shape of my graph look like this here. Now look, my x value underneath the radical is 1. My value outside the radical is 3. So I know this graph is going to begin at the point 1, 3. Oops, I don't know what that was. 1, 3. How about a y-intercept? Let's see if we can find a y-intercept for this graph. Find a y-intercept by setting x equal to 0. So I'm going to get y is equal to negative 1/2 times the square root of 4 minus 4 times 0 plus 3. Okay, 4 times 0 is 0. 4 minus 0 is 4. The square root of 4 is 2, so I'm going to get negative 1/2 times 2, which was the square root of 4 minus 4 times 0, plus 3. Well, negative 1/2 times 2 is negative 1 plus 3, which is equal to 2. So when x is equal to 0, y is equal to 2. I also have the point 0, 2 on my graph. And then what about an x-intercept? Well, if this thing is coming down this way, it certainly appears as though I'm going to have an x-intercept. How do I find my x-intercept? I find it by setting y equal to 0. So let's see if we can solve that problem. 0 is equal to negative 1/2 square root of 4 minus 4x plus 3. Subtracting 3 from both sides, negative 3 is equal to negative 1/2 the square root of 4 minus 4x. Multiplying both sides through by negative 2, 6 is equal to the square root of 4 minus 4x. Now I'm going to square both sides. I have to watch out for extraneous roots, but just to make sure, I see 36 is equal to 4 minus 4x. Subtracting 4 from both sides, 32 is equal to negative 4x. And dividing both sides by negative 4, negative 8 is equal to x. If I plug in a negative 8 up here just to check for extraneous roots, negative 8, 4 times negative 8 is, or negative 4 times negative 8 is 32. 4 plus 32 is 36. The square root of 36 is 6. Half of 36, half of 6 is 3. Negative 3 plus 3 is equal to 0. So sure enough, I do have a 0 at negative 8. So somehow I got to bend this thing down to go through the point negative 8, 0 also. Probably not the prettiest graph I've drawn, but if I make it big enough, maybe it'll look like it's a pretty good graph. Notice the shape of the graph goes down like this, begins at 1, 3, pretend that's actually beginning at 1, 3, goes through the point 0, 2, and goes through the point negative 8, 0. What's the range of this graph? Well, the range of this graph, look, it doesn't have a minimum, so it goes from negative infinity. The highest y value I can get, even though it looks like a little over 3, is actually 3. My range goes from negative infinity to 3. All right, what I've done, I've given you 4 functions. I'd like for you to try to do the functions. So pause the video and try the functions. When you've finished, turn it back on and I'll actually go through some of the answers with you. Okay, hopefully you were able to work these out by yourself. Let me just give you a few little pieces of these. Notice I've got 1, 2, 3, and 4. I actually just graphed them using the TI Nspire. This first graph here has, remember we find the origin by taking what's underneath the radical, setting it equal to 0. So I have an origin of negative 1. The y value out here is negative 2. The graph begins at negative 1, negative 2. When you set x equal to 0, you get the square root of 1 minus 2 is negative 1. So I also have the point 0, negative 1. To find my x-intercept, I set y equal to 0. 0 is equal to the square root of x plus 1 minus 2. 2 is equal to the square root of x plus 1. Squaring both sides, 4 is equal to x plus 1. And subtracting 1, x is equal to 3. So I also have the point 3, 0. For number 2, my x value of my origin is going to be 3. My y value of my origin is going to be negative 2. I've got 3, negative 2. The negative in front is what causes this graph to head in a downward direction. This little negative here in the front causes it head in a downward direction. I'm not going to have an x-intercept or a y-intercept. I just picked another point. I said, well, if this would be the square root of 4, I would know it was 2. Well, what's going to give me a 4? 7 will. So when I put a 7 in there, I got negative 2 minus 2, which was negative 4. Did you have to have that point? No, you didn't. If your teachers ask you for a second point, though, I would pick one that's a perfect square. That would give me a perfect square, so when I take the square root, I get something that's a little easier to graph. That's totally up to you, but you certainly needed the 3, negative 2. All right, for number 3, square root of 6 minus x. I'm going to find the x value of my origin of my graph by setting this equal to 0. So 6, well, out here I've got nothing. This graph begins at 6, 0. Notice the negative in front of the x underneath the radical is going to cause this graph to go off to the left. Therefore, we can be pretty sure that it is going to have a y-intercept. I find that by setting x equal to 0. Square root of 6 minus 0 is equal to the square root of 6. We know that the square root of 6 is somewhere in between 2 and 3, and so I've graphed my origin at 6, 0, and my y-intercept at 0, root 6. And finally, to find number 4, what I'm going to do for number 4 is I'm going to set what's underneath the radical equal to 0. 2x is equal to negative 4, so x is equal to negative 2. Looks like I forgot to put that point on there. Negative 2, 3 is where the graph is going to begin. Notice that there is a negative in front of the graph. That always takes a graph and flips it vertically. So I know I'm going to be heading down. I can find my y-intercept by setting x equal to 0. 2 times 0 is 0, plus 4 is 4. Square root of 4 is 2. I've got a negative out front. Negative 2 plus 3 is 1. So I have a y-intercept at 0, 1. And then to find my x-intercept, I set f of x equal to 0. 0 is equal to negative the square root of 2x plus 4 plus 3. Subtracting 3 from both sides, negative 3 is negative root 2x plus 4. So 3 is equal to square root of 2x plus 4. Squaring both sides, 9 is equal to 2x plus 4. Subtracting 4 from both sides, 5 is equal to 2x. I hope you can hear me and not have to just rely on reading this, because this number here is actually a 4. So x is equal to 5 halves. That's where we got the number 2.5, 0. We made this final graph. Hopefully these were not so bad. There are probably some, we're going to have another sheet that will give you a little bit more practice, and hope you enjoyed this tutorial.